I'm here to present the E4 company. E4 is an Italian company based in Reggio Emilia, close to Bologna. It's a 20-year-old company, and the company started as a system integrator for server system, but in few years changed the core of the company from system integrator to solution provider. In particular, currently the main focus of the core of the company is to propose to the customer HPC, high performance computing solution, artificial intelligence solution, and cloud solution. We are also strongly active in some European projects related to HPC world, in particular in partnership with many other companies and institutions in Europe. The story of the company: we did the first InfiniBand cluster in 2005. We did the first cluster with the ARM architecture, GPU, and InfiniBand 2 in 2013 for Barcelona Supercomputing Center. And the name of this cluster was Pedraforca, and is available online with some paper dedicated to this cluster. In the 16-17, we did the so-called Davide supercomputing system, the first in the top 500 built by E4. This system was a demonstrator, not a production system, but a demonstrator that is possible to have a system ready for the exascale, that is the current state of the art of the HPC in terms of computing power, the so-called exaflop system. And it was a demonstrator because he's in the first place in the so-named Green 500 list. That is the list of the top 500 system normalized to the power consumption. In the 2018, we found the E4 Analytics that is focused on the artificial intelligence and machine learning. We did also tool change for continuous integration and continuous delivery of our solution. What I mean is a tool change where we prepare our recipe that automatically deploy the software in our solution. We have also an E4 representative in Germany. And in the last year, we are engaged with Atos to the Bologna Technopolo, and we did the first RISC-V based cluster in the world. The name of this cluster is Monte Cimone, and I will show you something about in the next slides. We are member of many consortium like HiPiC, RISC-V, or the Open Lab, IFAB, and so on. You can see in this slide. Here you can see our standard solution for production, our system that are ready for production. You can both directly from some providers around the world. We have some high density system, high density in terms of GPU per unity of space. In the middle, we have the heterogeneous system with accelerator, and we have two kinds of accelerator, the FPGA on the top, and the GPU with this kind of server named NVIDIA DGX on the bottom. We can provide also storage system, and in particular high performance storage like parallel file system to use in conjunction with high performance computing. Our application and our software stack for different solutions are Medusa for HPC, Gaia for artificial intelligence, Captain is a container platform based on Kubernetes, Fluctus is a cloud platform based on OpenStack, and we have also a virtualization platform named vStone, and we have the vStone family with vStone, vShuffle, and TwinStone. Here, our space in our premises. In the first picture, you see the space where our technician integrate the server or the storage. In the middle, with the red ground, you can see the so-called burning room. Is where we place the server after the integration. We install automatically all the server, and then we start a period of at least 78 hours of burn-ins. That means we stress all electronic device with our software that we develop internally to test CPU, GPU, memory, I/O device, network device, to avoid the so-called early death of the electronic device and improve the reliability of the final solution provided by E4. In the right, we have a view of our R&D laboratory. In our R&D laboratory, we have 6 racks populated with different architecture of system. I mean Intel, AMD, ARM, RISC-V, Power, and other strange, let me say, strange server, only for production, only for R&D, not for production. A more detailed view of our space. The first is the burn-in space with our rack with wheel to move the server from one room to another one. In the middle, our R&D laboratory, and in the right, always the integration system, the integration space. Here, the laboratory with an active power of 100 kilowatt and many kind of architecture. We can provide to our partner remote access to test our system. With this, we try to be a step ahead in the technology offer. And here's some example of tailor-made solution. The first is Davide. Davide was the system in the top 500, the demonstrator of the availability of the potential sustainability of the exascale system. And we did in the past 2 papers, one published in the IEEE and the second in the ACM conference. And the first is the white paper that describe the overall system, and the second describe the power, the fine-grain power monitoring system developed in conjunction with the University of Bologna. We are in touch with Bologna and Cineca in particular to develop many projects together. Here, a detail of the David nodes with, you can see in the right, the pipes, because it was a system liquid cooled with 4 GPU, NVIDIA GPU per node and 2 Power8 CPU. The choice of the Power8 GPU was because it is the only GPU with the NVLink connection, that is a fast link, that connect the CPU and the GPU. Usually, the NVLink is adopted only for GPU-GPU connection. Only in this kind of architecture, you can have also, you can exploit this kind of connection between CPU and GPU. The system was connected with the InfiniBand Mellanox network to allow the low latency in the communication between nodes. Another system integrated by E4 in Napoli, in University of Napoli. The name is Purple Jeans. That is an upgrade of a previous E4 cluster named Black Jeans. Here we have an ARM ThunderX2 based cluster with 8 nodes and some NVIDIA accelerator. We used in the past to test and benchmark many applications, and in particular we did a molecular dynamics performance evaluation with model computer architecture, we compare the result of a molecular dynamics GROMACS application between ARM and two different kind of Intel, classical Intel system and a shared machine memory. That is a memory with many sockets and a big quantity of memory. I mean, of the order of terabyte of RAM. Here, a system designed for the Istituto Italiano Technology in Genova with liquid cooled, 16 rack, and many accelerators in each computing node. And the last year, the Tecnopolo in Bologna, where we did the installation with Atos. And currently we have 3 staff full-time on site for the day-to-day duty. Here, the Monte Cimone cluster. Monte Cimone is a mountain near Modena. We use this name for our RISC-V, this cluster. This is the first cluster based on RISC-V in the world. We develop this system in conjunction with Bologna and University and Cineca. Here we have some preprint and some paper about this system. We perform some benchmark tests like l'IMPACT, that is the test used for the top 500 list of the 500 more power supercomputing in the world. Stream test for the memory, and we install also some application like Quantum Espresso, that is an application of molecular dynamics. Here, an hardware view of the system with the 2 boards. Each blade is a dual system with 2 boards and 2 RISC-V GPU. The board is provided by C5, that is an American company. And we tested with Ethernet and all the software stack commonly used in the HPC system, like the scheduler, the user, the manager of the user, and also network file system, and many other software commonly adopted in HPC. And this was the goal of our project, to demonstrate that in this emerging architecture, all the software stack work fine. The last week, we have been on the HiPiC conference. This was our booth. In our booth, we show many posters about our activity in European project, and also one node of Monte Cimone on the top of the table. On the right, you have the view of the overall cluster that is currently in Bologna University. And we arrange also this workshop, RISC-V as cornerstone for the future HPC system. Here, the timeline of the European project where we are involved. Currently, we are involved in the European Processor Initiative, that is a program in Europe to develop the European GPU, to design the European GPU and the European accelerator, UPEX, to build the first pilot system based on the technology developed in the API project. In the Attract project, we have to build a board that generate truly random number from a random number source, electronic source. In Max, we develop or we help to co-design a system for the application in the field of material science. Taxteros, I will show you the prototype. We prepare a system with the so-called dual-phase cooling, that is a cooling system developed for nuclear reactor to remove the heat from nuclear reactor. Next, we test an application The name of this application is OpenFOAM, that is adopted in fluidodynamics, to understand if we have to improve the code for the next generation of exascale system available in Europe. In Ligate, the work is to improve the current CAD system to design drugs and improve also the methodology to develop the system to discover the drugs. In Maelstrom, we develop and help our partner in the development of 6 applications of machine learning for weather and climate forecast. In Rigale, we try to achieve better performance in terms of energy efficiency for the HPC system. Here, some real system. Here we have the Testarossa prototype with is a dual socket here and here. I don't know if you can see my arrow. And each CPU is ARM-based GPU with 128 core, physical core without hyperthreading at 3 GHz each one. And the system have also 2 FPGA as accelerator and the dual phase cooling. The partner involved in Testarossa, in particular, there is also Italian Institute of Nuclear Physics, but also Atos, Enea, CNR, e Barcellona Supercomputing in 4, e Fraunhofer in RIA, in France. In the European Processor Initiative, the goal of this project is to develop, to design the European GPU and the European accelerator. The first is based on ARM architecture and the second on RISC-V architecture. The first server integrated and validated in Europe will be hosted in Reggio Emilia, in the E4 premises in the next year. Here's some detail of the project, in particular the partner involved, like E4, but not only, the University of Bologna, ETH of Zurich, CIPERL and Atos, that are French company, and Barcelona Supercomputing, Fraunhofer in Germany, are partner of this project. Here, the RIA, that is a Neoverse ARM system, and it is designed by a French company named CIPERL. The APAC is designed by Bologna University and Barcelona Supercomputing Center. I move to EUPEX. Sorry for the music, I don't know why. Oops. Okay. In the goal of the EUPEX project is to build 2 different prototypes, both based on the RIA, that is the AP processor. One is GPU only, and the second one is with 2 GPU and 4 GPU in the same blade, with 1 rack unit of space. It's a very high density system with the liquid cooling. Some application will be designed to work in this kind of server or prototype for different field, in particular from INAF, Cineca, and CA in France. Well, what if for looking for the internship? We have 3 different possible positions. One is in the development of the tool chain for the continuous integration and continuous delivery of our software. In this case, the work is to build the tool chain with open source tools like Jenkins, Nexus, GitLab, and so on. These tools are already integrated, but we can upgrade the system or install new feature with new tools. Another possible involvement is in the development, maintaining, and validation of our SIPE for our solution, like HPC based on ARM or RISC-V. And in this case, the work is to write the code with Ansible, that is a language that describes the configuration of the system. Last but not least is the involvement in the EU project management, in particular follow the meeting and write reports about the meeting.